Persie with an early run, he's onside this time, it's 1-1.
Okay, so Junior Roberts here. So this question here says, a central midfielder and a winger stands 40 meters apart on the halfway line during the 84th minute of an intense football match. The midfielder intends to play a lobbed diagonal pass from the level ground with an initial velocity of 30 meters per second to an area 30 meters directly in front of the winger. So it says, if the ball takes 1.74 seconds to leave the midfielder's foot and land on the level ground, calculate the angle the ball must be kicked at with respect to the level ground in order for the ball to reach its intended target. So for this one now, what we first have to, let us say we first consider a football field. Let us say we sketch a football field right here. So let's say this is our football field like this. And let's say this is the halfway line. Say this is the halfway line like this. Right? So that's the halfway line. Now let's consider that the midfield player is standing here. Let us say this is the midfielder standing right there. Let us say this is the winger. So the winger is probably standing here. So that's the winger, right? And the ball is to be played into an area. Let us say this area. We're gonna call it P. So the ball will be played into this area P, which is, as the question says, it is 30 meters directly in front of the winger. So let's consider that from here to here is 30 meters. So this is 30 meters right here. And the ball will be played from M to P, which will have some distance like that. Now, if you observe this, you'll realize that in this setup right here, we have a right angle triangle being formed between the midfielder, the winger, and the point at which the ball will be kicked to. So now, if we look closely right here, we realize that, okay, this is a triangle, a right angle triangle, and we can use the right angle triangle to find out this distance. Let us say we call this distance S, which is the displacement of the ball from the point at which the midfielder will kick the ball to where the ball is supposed to go. So we're going to see, using Pythagoras, that S is equal to, and again, notice that the distance between the midfielder and the winger would be 40 meters. So from Pythagoras, we can say that S will be equal to the square root of 40 squared plus 30 squared. And this now will evaluate to the square root 40 squared. Let's just plug it into the calculator just so we see. So 40 squared is 1600. So 40 squared. So 1600 plus 30 squared, which is 900. Now when we add these two together, we're going to see that we're going to get a value of 2500. So S then now will be equal to the square root of 2500, which is 50 meters. So therefore now what we're going to see now is that the ball will be kicked a distance of 50 meters along this straight line. So we're assuming that the ball will be traveling straight line like that. And again, it's a lobbed overhead pass. So we're assuming that it's going to travel overhead in a straight line towards P. Now, that's how we need to calculate the angle that the ball must be kicked at with respect to the level ground in order for the ball to reach its intended target. So for this now, we can consider motion in the horizontal plane. So we can consider that S is equal to U cos theta multiplied by t. So let me rewrite that. So we have s is equal to u cos theta times t. And in this case, we want to find the angle that the ball must be kicked at to reach its target. So we need to find this value theta. So if we rearrange, we can get that cos theta is equal to s divided by ut. Right? So cos theta is equal to s divided by ut. So moving this up here, we can write that cos theta is equal to 50 divided by u. U again was 30 meters, which is the 30 meters per second, which is the initial velocity. So this becomes 30 meters per second multiplied by t, which is 1.74 seconds. So now we're going to get that cos theta is equal to, let's simplify this, of 50 divided by 30 minus 1.74. Let's evaluate that. 30 multiplied by 30 multiplied by 1.74 gives us an answer of 52.2. So the cos, let's get this out of the way. So the cos of theta is 50 divided by 52.2. So what we're going to get now, let me just simplify that. So 50 divided by 52.2 gives us an answer of cos theta is 0.96. So therefore now, theta will just be equal to the inverse sine of cos inverse cos. So theta then now is cos inverse of 0.96. So now we will see that the angle theta, taking the calculator, we say shift cos 0.96, and we get a value of 16.3 degrees, or in other words, roughly 16 degrees. So the angle that the ball must be kicked at with respect to the ground will be 16 degrees. So now, let's see what's next. So next it says we're to determine how long before the pass is made, the winger must start his run to receive the ball on the level ground. And we're assuming that the winger runs in a straight line at a constant speed of 8 meters per second. So again, we have our situation right here. So we have the two players at this position, and the ball will be kicked at some distance, and we actually figured out that distance to be 50 meters, right? And the winger will have to run a distance of 30 meters to get to this point. Now we know that the ball takes 1.74, let's just double check it, 1.74 seconds to travel 50 meters, right? And the winger will travel 30 meters in a given time. So let's say we try to find the time that the winger will take to travel 30 meters. Let us say time for the winger is equal to, so let's first consider, so since we said that it was running at constant speed in a straight line, we can consider that the velocity is constant. So we'll consider that velocity is equal to the displacement over time. Now, the displacement in this case would be the 30 meters that the winger will have to run. So therefore now, we're going to see that t now is equal to the displacement divided by the velocity. And again, this time is the time for the winger to run 30 meters. So this now would be 30 meters divided by his speed, which is also equal to his velocity, since he's running in a straight line, is 8 meters per second. And we see from this that time for the winger to run 30 meters to meet the ball would be 30 divided by 8, which is 3.75 seconds. So the time for the winger to reach the ball would be 3.75 seconds. Now, we want to know how long before the pass is made that he would need to start running. So since the ball would take 1.74 seconds to reach, he wants to start running a little while before the ball is kicked. So we want to know, okay, what's that time? So let's say now that the time t would be equal to the time that he would take to run minus the time that the ball takes to travel the 50 meters. So we're going to say 3.75 seconds minus 1.74 seconds. And this now works out to be, let's see now, 3.75 minus 1.74. So that's 2.01 seconds. So you would want to start running approximately 2 seconds before the ball is kicked in order to be at the position 30 meters in front of him when the ball is at that point. So let's see what's next. So next thing now, it says we're to calculate, it says the winner. So it says here that the winger adjusted his run so that he intercepts the ball 1.4 seconds after it was kicked. Calculate the height the player has to jump in order to head the ball towards goal if the winger is 1.85 meters tall. So let's see. So we want to find out, okay, the height that the player has to jump in order to head the ball. So let's consider a situation now. So we have the ball being kicked and it is traveling and we expect it to land on the ground 1.74 seconds after it has been kicked at some distance of some displacement of 50 meters from its initial position. Now what we're saying now is that the winger will intercept the ball 1.4 seconds after it was kicked, so therefore we would expect that the ball will be in the air at that point. So the winger will be intercepting the ball when it is in the air. So we need to know, okay, how high in the air the ball would be. So let's consider motion in vertical. So let's consider some vertical motion. So let's say we use S is equal to U sine theta multiplied by T minus a half GT squared. So again, the ball was intercepted 1.4 seconds after it was kicked. So let's put down some variables now. So our displacement, S, is unknown. And again, this is a vertical displacement. The time is 1.4 seconds. We know that acceleration is minus G. What else do we know? Theta, what was theta again? 16, let's use 16. So theta is 16 degrees. What else do we know? And we know that the player is, so let's say the player is 1.85 meters tall. So let's plug in some values here now. So here now we're going to have S is equal to U. So U was 30 meters per second, right? So the initial velocity was 30 meters per second. So now U say was 30. So this is 30 sine theta, which is 16. So we're using 16, and we're going to multiply this by T, which is 1.4 seconds, minus, so let's put a bracket around here. I'm going to put the units. Let's just put a bracket and 1.4, close bracket, minus a half. G is 9.8. So 9.8. So put a bracket around this. And we multiply it by T squared, which is 1.4 squared. So let's evaluate this now. So this now becomes, taking the calculator, we say 30 sine 16 multiplied by 1.4. This becomes 11.6 minus, so say 9.8 times 1.4 squared equal, divide by 2, and we get 9.6 in this case. So therefore now S is equal to 11.6 minus 9.6, which works out to be 2 meters. So therefore now the ball will be 2 meters in the air. So therefore now, in order for the player to head the ball, since he is 1.85 meters tall, the player will have to jump. So let's say now that the height that the player would have to jump, h, would be equal to 2 meters minus 1.85 meters, and this would work out to be 0.15 meters. So he will have to jump roughly 15 centimeters in the air in order to head the ball. Alright, so this was Junior Roberts. If there are any questions in this video that you wish to get further clarification on, post it below and I'll do my best to clear up any misconception. Like this if it was helpful, and click subscribe on the bell so you're notified whenever I post new videos like this. Thank you for watching.
Just pausing between the fullback and the centre half. Ramos has gone to sleep, certainly not offside. What a pass it is from Blint as well, and the perfect header, almost